All right, guys, this is going to be our first lesson in this new part here that we're learning. So last section, we covered surface area. Now we're going to move on to volume here. So this whole part that we're going to be testing over is over volume. And the first part's going to be over volume of prisms and cylinders. So let's get into our essential understanding here first. So volume is the space that a figure occupies. It is measured in cubic units, such as cubic inches, cubic feet, or cubic centimeters. So again, the exponent that that's is going to have is a 3 now. So anytime we see the word volume, understand that the units that we're going to use, whether it's inches, centimeters, whatever it may be, all those units are going to be cubed. Okay. The volume, or V, of a cube is the cube of the length of its edge, E. So essentially, since all the sides are the same there, it's just going to end up being E cubed. So again, a cube is the same thing as all the sides are being a square, so that's why it's E cubed. You can find the volume of a prism of a cylinder, or of a prism or a cylinder, when you know its height and the area of its base. So both stacks of paper below contain the same number of sheets. The first stack forms an oblique prism, and the second forms a right prism. So the stacks have the same height. The area of every cross section parallel to a base is the area of one sheet of paper. So the stacks have the same volume. These stacks illustrate the following principle. All right. So again, these are just good ways to show you what an oblique prism looks like and what a right prism looks like. So again, make sure you understand what the difference between the two are. Okay. So one of the principles we'll be covering today, Cavalari's principle. So in this principle here, it is if two space figures have the same height and the same cross-sectional area at every level, then they have to have the same volume. So again, that goes back to what we just saw there in our oblique prism and with our right prism, right? So again, here's our examples of what we just saw. The area of each shaded cross-section, again, the cross-section is, if I were to cut it in half, open it up, and see what shape's on the inside there. That's what it's talking about. As long as they have the same shape on the inside, if they're both squares, then they're going to have the same volume. So that's what Cavalari's principles here is talking about. So since the prisms have the same height, their volumes must be the same by Cavalari's principle. You can find the volume of a right prism by multiplying the area of the base by the height. So again, Cavalari's principle lets you extend this idea to any prism. So again, in words right here, we're going to see what the volume of a prism is. Kind of what we've been saying here multiple times. The volume of a prism is the product of the area of the base and the height of the prism. So again, your basic formula is going to be V equals big BH, where big B represents the area of the base. So first find out what shape your base is, find the area of that shape, and then multiply that, whatever your area comes out to be, times the height of your figure, and then that's going to give you your volume. Area of the base times the height. Okay. Example 1, finding the volume of a rectangular prism here. So again, they tell you what your base should be here. A rectangular prism means that your base is a rectangle. So when it asks you what's the volume of the rectangular prism here, what you're going to first do is use your formula of V equals BH. All right. So again, knowing that we're using a rectangular prism, that means our base is a rectangle. So knowing that, then we're going to do the area of a rectangle, which is just going to be base times height. So first off, we're going to multiply the base here. So the area of the base here is going to be base times height, which is 24 times 20. So if I type that in my calculator, 24 times 20 does end up giving me 480. So my area of the base is 480. Then from there, I'm going to multiply it times the height. So again, going from one base to the other base, what's the height between those two? That's that 10 centimeters right there. So then I'll multiply that 480 times 10, and that's going to give me the answer of 408 or 4,800. So again, the volume of this rectangular prism, 4,800 centimeters cubed. So again, remember, for our units, the units have to be cubed. Okay. Example 2, finding the volume of a triangular prism. So again, they tell you what kind of base we should be looking at here. So if I hear the word triangular prism, that means that our base is the triangle. So again, my first step here, find the area of the base. So again, I'm finding the area of a triangle. If you don't know, the formula of an area of a triangle is 1/2 base times height divided by 2. It's all the same. So again, that's my first step, find the area of my triangle. So again, we're using our formula of 1/2 base times height here. Now, with our triangle here, we know that this is an isosceles triangle since we have two sides that are the same. They're both 8 inches. Now, unfortunately, they did not give us the height there. So for us to get that, I would then draw a vertical line through there, and that's going to be the height, right? So again, we know that in an isosceles triangle, right? In an isosceles triangle, that our it's an equilateral triangle. And again, we can tell it's equilateral here because all three sides here, since this is a rectangle, opposite sides are going to be congruent. That means that all three sides are the same. All right, so we have an equilateral triangle, which means since all sides are equal, all angles are going to be equal. So in an equilateral triangle, all three angles should end up being 60 degrees because 60 times 3 ends up giving us 180. So from there, when I'm finding that height there, if I draw that vertical line like we see in that picture below right there, that ends up bisecting that top angle right there. So half of 60 would mean that 30 goes on each side. And then I have 30, 60, and then that middle angle is going to be a 90 because it's perpendicular. That height's perpendicular with the base. If that's the case, we're looking at a 30, 60, 90 right triangle. Again, that height bisects that side also, so each side still becomes 4. The full side still is 8. But if we're looking at the smaller triangle there, we're looking at a 30, 60, 90. So going from a short leg to a long leg, we multiply times radical 3, which is how we got our 4 radical 3 right there for our height. So there's our height. We're going to multiply the height times the base, and the full base right there, 4 plus 4 is 8. So 4 radical 3 times 8 right here, right? And then now we're going to multiply those two numbers and then divide by 2. So 8 times 4 is 32. And then divide that by 2, that gives us 16 radical 3. So we're going to leave that in the radical form just to kind of keep it easier for ourselves. Then we're going to multiply, once we have the area of the base, then we're going to multiply it times the height. So again, that height is what separates our two bases. So there's our two triangles. The distance between those two is the height, which is that 10 inches right there. So I'm going to multiply that 16 radical 3 times the height, which is 10, which gives us 16 times 10, which is 160 radical 3. And again, since they say they want the approximate value there, that means that we're going to get rid of that radical there. So I'm going to type in my calculator 160 times radical 3. And again, you're going to get a decimal there, but we want the approximate, which means we're going to round out the nearest whole number. So it should give us, when rounded, 277, which is letter B. Okay. So again, you got to know your special right triangles because we may see some of that. We may see a 45, 45, 90 as well. So again, make sure you're recalling these things that we learned earlier on in the year. Okay. Volume of a cylinder here. So to find the volume of a cylinder, you use the same formula, V equals BH, that you use to find the volume of a prism. Now, however, B is the inside of the area of a circle. So you use the formula B equals pi r squared. That's the area of a circle, pi r squared, to find its value. So again, to find the volume of an area, you can either use BH or you can use the formula of pi r squared H, which is what I would recommend you use. So again, for a cylinder, you use pi r squared H. That's the formula we're going to end up using here. All right, so let's look at an example here, finding the volume of a cylinder. So what is the volume of a cylinder? In terms of pi, that means we're not multiplying pi into our equation here. You're going to save that for the end. So again, all we're multiplying here is the radius squared and the h. So again, my first step, go over here, find what my r is, find what the h is. My r right there in that circle is 3, so there's the r. The height, again, since it's a cylinder, we're looking between the distance between my two circles, that's 8. So when I plug those numbers in, I have pi 3 squared times 8. And again, all we're doing there, 3 squared is 9, and 9 times 8 gives me 72. Remember, they want it in terms of pi. That means we do not multiply pi into that answer there. So this answer should be 72 pi centimeters cubed. Again, volume, you use cubic units. Okay. All right. We're going to stop there for today, guys. Your homework will be due by 11:59 on Tuesday, April 27th. Again, I will have office hours today from 1 p.m. to 2 p.m. And again, like always, if you have questions or concerns about anything, please feel free to contact me. You can remind me. You can email me. Get in touch with me any way you need to, guys. But this is the first lesson for today. I hope you're staying on top of your work. And again, like I said, if you need me for anything, guys, I am here for you. But other than that, let's get off to a great start, guys. Have a great day. See you.